Hi everyone. So this is the discussion of week 5 for the best first search and A-star algorithm. So this is the graph they had given for us to calculate the best first search. Okay. So what they are asking us to calculate is the path found by the best first search algorithm and the path cast. So while going to the best first search algorithm, this is the graph they had given to us, and what we have to do is first, for best first search, we are having the f of n is equal to h of n. That is the heuristic value, meaning that the estimated distance from node n to goal node g to goal node g. Okay, so before starting the uh, algorithm, we need to find all the h of n values. So if we see for a, this is the node and this is the h of n value. For node A, what is the h of n value? So 1, 2, so for calculating here, they asked us to take the h of n as the Manhattan distance. So Manhattan distance, we need to travel either in the x direction or in the y, parallel to x axis or parallel to y axis. Now if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so each this is having the 10. So if you multiply that with 10, what will get? A is equal to 200. So A is equal to 200. So be careful whenever we are calculating the h of n values. Don't go beyond. So whenever we are traveling like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you should not go beyond this one. G is here only. Okay, so you have to go again in this direction. Otherwise, you can go this direction and like this also, meaning that along y-axis first, then, but you should not go beyond this y, either in x-axis or in y-axis. You should have to consider up to this particular point only. Okay, so like that you have to calculate the h of n values. So for a, b, like that, first to calculate and note down the values. Okay, next by using the best first search, so f of n is equal to h of n. First, we'll take as open list and the closed list. So first, open list S is there, then S will be moved to closed list. And what are the nodes connected to S? So the nodes connected to S are A, C, I, K. Okay. So A, C, I, and K. So A is having 200, C is having 170, I is having 120, and K is having 150. So after writing all these things, you see which is having the lowest perfect value among these ones. So which is having the least, I is having the least. So the least value, least perfect value, the node with the least perfect value is moved to close. So I will be moved. So along with this one, I will write parent node. Yes is the parent node. Here, yes is the parent node. So why I am writing parent node here is whenever we want to find the path, then the parent is required for that particular. So I is coming from yes only. That's why I wrote the parent of I is equal to yes. Now the nodes are in the open list A, C, A with 200, with 170, and this one 150. Next we need to write the nodes connected to I. So what are the nodes connected to I? L, M, H. So write L, M, H. So L is having 110, M is having 80, H is having 100. Now see which is having the least among these one. So M is having the least. So write M. Parent of M is equal to I. Okay. Now you see what are the nodes in the open list. Now we are having A, C, K, L, H with 200, 170, 150, and 110 and 100. Whenever we are moving M to the closed list, we need to add the nodes connected to M. What are the nodes connected to M? We are not having any nodes connected to M. So next minimum. Next minimum is H. So we are not having any nodes connected to M, thus we are not adding any nodes to the open list now. Next we will see which is the node with the lowest. H is having the lowest. So move H. H, what is the parent of H? Parent of H is I. So after expanding I only we got H. So that's why I'm writing parent of H is I. So now what are the nodes already existing in open list? First write already existing A, C with 170, A with 150 and L with 110. Now write the nodes which are connected to H. The nodes connected to H are J, F, D. Okay. So J, F and D. J is having 90, F is having 130 and D is having 160. Now see which is having the minimum value. Now J is having the minimum value. Now move that J to the closed list. So again here open and continue here and closed. So J is more. So what is the parent of J? J parent is H. So after expanding H only we got. So what are the nodes remaining in open list? Restart all once again. So A, C, K, H, L, A, C, K, H already completed, no? A, C, K, L, it is not there. A, C, K, L, F, D, F, D, and moving J. So what are the nodes connected to J? J is connected to only N. So write N here. Okay. So I'm not writing all the values. N is having 50. Okay. Now which is having the least one? So all the previous are having highest values. So now N is having the minimum. So now move N. So what is the parent of N? After expanding J only we got N. So write the parent as Z. Now you see what are the nodes connected to N. N is connected to G and Q. Okay. Now N is connected to, so along with these nodes plus we are having G and Q. G is having the token value 0 and Q is having 40. Okay. Next which is having the minimum? Next Q is having the minimum. Sorry. G is having the minimum. So now move the G to the closed list. This is the parent of G. After expanding N only we got G. So N is the parent. Okay. So now you got the goal node. Whenever you identify it is a goal node, then stop the algorithm. Now when after completing this one, to write path, come in the reverse direction. Okay. First G. Which is the parent of G? N. What is the parent of N? J. What is the parent of J? H. What is the parent of H? I. Okay. What is the parent of I? I parent is yes. S. Okay. Now write in the reverse order. So the path of best first search is best first search is S, comma I, comma H, comma J, comma N, comma G. Okay. So the path cast for calculating, list out the values from S to I. So S to I is 60. Okay. So 60 plus I to H. I to H is 80 plus H to J. H to J is 60 plus J to N, N to G. J to N is 50 plus 60. So 50 plus 60. So how much you will get? 310. So this is the path cast and this is the path and this is the path cast by using the best first search. Okay. Okay. So this is the path S, I, H, J, N, G and this is the path cast. Then by using the A star algorithm, we need to see the same algorithm we need to consider for A star algorithm. For A star, f of n is equal to h of n plus g of n. H of n is a heuristic value, is the distance from n to g goal node, and g of n is the distance from start node to goal node. Okay, previously we consider only the h of n, now we are adding both h of n and g of n. The same procedure we have to follow, whatever we followed, that is open list and closed list. Okay, so open and close. So first open S, move S to the closed list. The nodes connected to S are A, C, K, I. So write A, C, K, I. Now previously we took only the h of n values. Now we need to consider both h of n values plus g of n values. So h of n is 200, h of n plus g of n. So g of n is the distance from start node. So for considering A, the distance from start node is 40. So plus 40. So that is equal to 240. For C, it is C, it is 80. First I will write this 170 plus 8. That is equal to 250. And for K, 150 plus 50. That is equal to 200. For I, 120 plus 60. That is equal to 180. So which is the minimum? I is the minimum. So I will move the parent is yes. Now after expanding I, what are the nodes connected to I? Again M, H, L and C. Okay, so already we are having A, C, K. Along with that one H, comma, L, comma, M, and once again I am writing C here. Already we are having AC. Previously, whenever we are doing the best first search, I didn't write once again this is C whenever we are seeing the nodes connected to I. Because we are considering only the h of n value. Thus, if I include the C, the same h of n value should be right here. But here, again I am writing the node which is already existing in the open list. I will tell the reason why. So A is having 240 previous values. C is having 250 and K is having 200. Now H, L, M, C. Okay. So what is H of n values? First this one is 140 and L is what is the L value? 110. H is 100 and L is 110 and M is 80. Okay, so H with 100, L with 110 and M with 80 and C with 170. Now place G of n value. So G of n value is the distance from the start node. Okay. Now while expanding the I, previously when expanding C, I reached C. So there I wrote the 80 is the G of n value. That is starting. Now I came from S to I. Again I am coming to C. Now what is the distance from particular node C to the starting node? So this is the distance. So 60 plus 60. Now I need to write 120 here. 120. Okay. So this is the C value now. Normally it is greater than the previous value. So we can remove this one. But sometimes assume that whenever we are adding these two distances may be less than this 80. At that time, whenever you get this, at that time we will get this value, whatever the newly calculated value is less than the previous value. At that time we have to include this value and we have to remove this value whenever it is less. But now in this our case, it is higher than the previous value. So we are neglecting this value and keeping the previous value as it is. If it is greater than the previous value, then neglect. If it is less than the previous value, meaning that always we have to consider the least value. That's why the path, meaning this one is coming from S to C, is having the higher value when compared to this one. Then we'll remove this path and we'll consider this path. That's why we are removing this one and we consider the tips. So whenever it is less, take it as the newly one. If it is greater, neglect this one and consider whatever the previous value. Now we got higher value, so neglect this one. So for H plus, what is the H value we'll get? For H, 80, 60 plus 80. So that is 140. So we'll get it as 240. And for L, 105. For L means from S to I and I to L. So now we are moving from I, S to I and I to L. So we need to calculate G of N like that. So that is from now S to I to M. That is 110. So this is for L it is 215 and for M it is 190. Okay. Now consider the least one, which is having the least. Which is having the least? M is having the least. Now move that M to the closed list. Okay. Now open and close. So M will be moved to the closed list. What is the parent of M? After expanding I got M. So I am writing I as the parent. So previously we are having A with 240 and C with 250 and K with 200, H with 240, L with 215. So these are the HLM and ACK. ACK, HL, M is moved to the closed list. Now you see what are the nodes connected to M. We are not having any nodes connected to M. Okay. Now next consider the least. Next consider the least is which is having the next one. K is having the minimum 200. So move K to the closed list. What is the parent of K? Now you see here. Here we are added the K. So that is the parent is yes. So after expanding yes only we inserted the K in the open list. So the parent of K is yes. So now what are the nodes already we are having? Yes, A with 240, C with 250 and H with 240 and L with 215. And after expanding K, what are the nodes we are having for K? So K is having O and P and again L. Okay, again L is also there. LOP. Okay, so already L is there. Now once again we write LOP. So this is from S to K, K to L. So whenever I am writing here the G of N, S to K, K to L, the distance as the G of N now. Because this L, whatever this L we are getting after expanding the K. So that is K is having the parent as S. S to K, K to L. Okay. So this is, what is the L value? So if we get 110 plus 110, that will get it as 220. And for O, 120 plus 90, that is equal to 210. For P, 130 plus 120, that is equal to 250. One value is of N, one value is G of N. Now you see previous value is 215, the new value is 220. So new value is higher, so neglect this and consider the last one only. Okay. Now see which is having the minimum now. ACH LOP, which is having the minimum. O is having minimum 2. Now move that one to the open and close. Move O. So which is the parent of O? After expanding K only we got O. So K is the parent. Now what are the nodes already? A, C, H. We are having A, C, H, A with 240, C with 250, H with 240 and L with 215 and O we are moving P and P with 250. P with 250. Now we have to write what are the nodes connected to O. What are the nodes connected to O? P, R, Q. Okay. So the nodes connected to P, Q, R. So T is having 170 plus 90, that is equal to 260, and Q is having 200 plus 40, that is equal to 240, and R is having 170 plus 50, that is 220. Okay. Now see which is having the minimum. Which is having the minimum? L is having the minimum. Okay. Move that L. What is the parent of L? L where we wrote. So L is the, after expanding I wrote L. So the parent of L is I. Parent of L. Now you see these are the nodes, and you see what are the nodes connected to L. Okay. So again M, Q, O. Again L is connected to M, Q, O. So along with this one we are having, I am not writing this plus M, Q, O. So M is having 145. So whenever we are calculating, we need to consider the distance from L. That is the, after reaching I, next. That means I, we got I. So from here, I, yes, S to I to L, L to M. Okay. So 145 plus 80. So this will get 225, and 185 plus 40. So we'll get it as 225. O is 155 plus 90. So we'll get it as 245. Okay. Next we see which is having the minimum. Next which is having the minimum, R is having the minimum. So R, move that R to the closed list, and which is the parent. After expanding O you got. So the parent of R is O. Okay. Now see what are the nodes connected to R. The nodes connected to R are again G, Q, V. Okay. So G, Q, V. Okay. Now write what are the values we are having for G and Q and V. So for G, I'm writing in the next slide. G is having 230 plus 0, that is 250, and Q we are having 250 plus 40, that is 290, and V is having 220 plus 50, we'll get it as 270. This is 290. Okay. So which is having the least one? You see these are the values we're having. 260, 225, to which is having the least one. Q. Okay. So M and Q both are having the same values, 225, 225. Whenever both are having the same, we have to follow the alphabetical order. So A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q. So according to alphabetical order, we need to follow the M. Okay. But you see, M is already there in the closed. Okay. So M already is there in the closed. So I'm not considering M now. I think I moved that M to the closed list. Already M is there in the closed list. Okay, M already moved. So we are not considering M, this M. And the next is the Q. Okay, so next to move, you see this Q is 225 and this Q is 290. So neglect this Q. Okay, previous Q only we are considering, this Q only. Okay, so 225 is there. So move that Q to the closed list. So from where we got this Q? After expanding L. Okay, so the parent of Q here is L. Okay, now we see the what are the nodes connected to Q. Q is connected to Z, R and N. Okay, so G, R and N. Now you see what are the nodes connected G, that is from Q to L. L where from you got L. If you see what is the, how to calculate the G of n value now is, so Q, this is Q to L. From where you got L, L to I. So where you got I to S. So S to I, okay, then I to L, L to Q. That is the G of n value and H of n value already. So 235 plus H of n value is 0. So we'll get 235. Now you see, when compared to the previous, this value is less. So remove this value and consider this value now for the Z, because this is having the lowest value. Okay. Now F and R, and F R is having 275 and the N is also having some value. Now which is having the minimum among all these things? 225. So 235 is the minimum. So move this G. So what is the parent of this G? Parent of this G is where we expanded this G, after expanding Q. After expanding Q only we are writing. So goal node is completed. So G Q G Q L G Q Q Q only this value. No? Once wait. This is not 250. This is 230. This is 230. Okay. So we have to consider this value only. So from where you got this Z? This Z you got from R. So after expanding only. Sorry for the company. This is 230 only. So G to R. Okay. R we got from O. O we got from K. And K from S. So the part is S, K, O, R, G. The part cost we calculated as S to K. S to K is 50 plus K to O is 70 and O to R is 50 plus 60. So we'll get it as 230. Okay. So this is 230. This is 235. So his is higher. So we are considering previous one only. That is 231. If it is less, then we have to consider this one. Okay. So the values are, so first they asked from node second node to the sixth node. Second node to the sixth node. So what is the first node is S, second node is I. I is the next move to the closed list. After I, M, K, next node is K, next to O. Next to O and next to L, like that it goes on. So they are asked us to write from the second node to the sixth node. I, M, K, O, L. I, M, I, M, K, O, L. Okay. So they asked us to write the F values. F values for that one. Okay. So first for I, what is the 180? 180. Next for I, next M, next K, 200. M is having, what is the M value? 190. K is having 200. Okay. Next K, O value is 210. Like that we have to write the F values. Okay. 180, 190, 200, 210, 250. What is the path? SKORG. Path cost is 230. Okay. Thank you.